Okay, so I'm going to go ahead and explain how we're going to do probability when we have different combinations. Combinations are a way that we can actually calculate, like if I'm going to put you guys in groups and I have a group and I have a class of 30 and I want groups of 5, I can actually do what we call a combination, and that would actually tell me all the different types of grouping that I could actually have. Actually, that would be combinations. The order doesn't matter. Permutations, order does matter. I'm not going to make a video on permutations, but we will go over them in class. Combinations are kind of handy to know. I'm going to work the same type of problem, but this time I have 5 marbles in a bag. And in this bag, I have 3 cat eye marbles and then 2 black marbles. So the type of combination we're going to have to talk about sample points, a sample space, how to actually calculate this out. So this is probability with combinations, and I'm going to have 5 marbles. Of that, I have 2 black marbles and I have 3 cat eye marbles. And what we're actually going to do is I'm going to pull 2 at a time, and from that I want to actually calculate what's the probability of the 2 types that I actually pull out. So the way to do this is we're going to actually have to create what's called a sample. We're going to write out sample points and then do sample sets. Then I'm going to actually show you a quick way you can actually calculate a combination by hand, because what we're actually going to do, we have 5 marbles, we're going to choose 2 of them. So let's do this. So what I'm going to do is I have a lot of different scenarios. I have a black marble 1 and a black marble 2. Then I have a cat eye marble 1, a cat eye marble 2, and a cat eye marble 3. So we're going to pair these up. So I could pull the black eye marble, so I can do black 1, black 2. That's one option I have. Then I could also pull black 1 and cat eye 1. I could pull black 2. Let's keep it with black 1, cat 2. Black 1, cat 3. Then of course I could do black 2, cat 1, black 2, cat 2, black 3, no black 3s, black 2, cat 2, and then of course I have my combinations of cat 1 with cat 2, cat 1 with cat 3, and of course cat 2 with cat 3. And I wrote it like this because it's going to make my life a little easier when I actually go to calculate things. So the first thing I'm going to look at is I'm going to count how many total different options I have here. And if I did it right, I should have 21. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I have 10. It should be 10. So I have 10 total. In this column here, I have 1 out of 10 that could work. 1, 2, 3, 4, 5, 6. I have 6 out of 10. 1, 2, 3, and I have 3 out of 10. If I add these up, I should get 1. That's kind of the magical number with probability, which you could see 3 plus 6 plus 1 is 10. So I have 10 over 10, which is 1. Now, another way that I could check to make sure I have all of these is actually to calculate the combination. It's nice. The formula is going to look bad, but it's really not that bad. So we can actually we're going to do 5, choose 2. So what this is capital N, choose lowercase n, and my formula is capital N factorial over lowercase n factorial times capital N minus lowercase n factorial. Told you it's going to look bad. But this is actually really easy to calculate by hand. Factorial, all that means is we're going to start at the highest number and we're going to multiply all the numbers going down to 1. So in this case, 5, we're going to do 5 times 4 times 3 times 2 times 1. But there's some shortcuts we can actually do this by hand. I'm going to show you how to put it in the calculator too, so it's not terribly bad on y'all. So here we go. So in this case, my capital N is 5, my lowercase n is 2. So I'm going to have 5 factorial over 2 factorial times 5 minus 2 factorial. Calculate this out. I'm going to do 5 times 4 times 3 factorial, and I'm going to show you why in a second. I'm going to have 2 times 1 times 3 factorial, because 5 minus 2 is 3. Well, look, my 3 factorials cancel out, so I don't actually have to write it all the way out. You can if you want. This just simply gives me 5 times 4, which is 20, divided by 2, which gives me 10, which is how many actual outcomes I had. Each one of these individuals is called a sample point. This entire thing right here is your sample space. So this is the space of all of my samples, and each individual one is a sample point. So when I pull 2 out, the probability of me actually getting, so my probability of pulling out a black and a black is going to be 10% of the time, or 1 out of 10. The probability of pulling out a black and a cat eye is going to be 60% of the time, and then the probability of pulling out a cat eye and a cat eye is going to be 30% of the time. Okay, so let's do a quick experiment. Cat eye, cat eye. Let me go chase it down. Sometimes I feel like the Three Stooges. All right, so my theoretical probability I should get black cat eye 60% of the time. But my experimental probability of getting a black cat eye was 9 out of 10, which was 90% of the time. All right, the probability of getting black and black was 0 out of 10, which is clearly 0% of the time. And the probability of getting cat eye was 1 out of 10, which is just simply 10% of the time. And once again, what's really nice about this is we have 2 stark different numbers here. But the more that we would have done the experiment, the closer we would have gotten to our theoretical probability because of the law of large numbers. Hi, I'm Mr. Buzzard, and I'm making these videos as supplemental instruction for my students. If you found these videos actually informative, or they answer the question you're looking for, make sure you hit the like button, and then don't forget to subscribe and then click the bell to receive notifications for future instructional math videos.